Welcome. We are going to discuss continuity of a function. What is meant by continuity of a function or how to determine it? A function, in one way I can say, while plotting the graph of a function, if we are lifting the tip of the pen at a particular point, at that point the function is discontinuous. And if we are not lifting the tip of the pen, then at that point the function is continuous. This is the easiest way. Let us take an example. Fx equals to mod x. Fx equals to mod of x. What will be the graph of this function? This function can be drawn like this. So while plotting this function, see from here to here we are coming and then we are going in this direction and we are not lifting the tip of the pen, hence the function is continuous at every point. And if we are taking another function, suppose fx equals to box of x. You are knowing box of x, that is called greatest integer in x, not greater than x. So from 0 to 1, it will be 0. At 1, suddenly it will jump, it will come here. At 2, it will be like this. At 3, it will again come here. In this way, what we are observing, at 1, we are lifting the tip of the pen. At 2, we are lifting the tip of the pen. Hence, in this way, it can be calculated that the function is discontinuous at every integer point and this function is continuous at every point. But come to practical problem. There may be different questions where plotting a graph may not be easy. So we need an alternative method. What may be the alternative method? That is called analytical method. Analytical method, what we are calculating, suppose we are for any function x, for any function fx, we are interested to calculate that at x equals to a, whether the function is continuous or not. We have to calculate one by one. Suppose we are calculating limit x tends to a minus. That means when x is moving towards a from values less than a, whether that limit exists or not. If limit does not exist, immediately take a decision that function is discontinuous at x equals to a. If limit exists, we cannot take a decision yet. Then we have to find limit of fx, x tends to a plus. That means the x, when x is moving towards a from values greater than a, then limit exists or not. If limit does not exist, we will say the function is discontinuous at that point. If limit exists, then we have to check whether this limit and this limit is equal or not. If it is unequal, immediately take a decision the function is discontinuous at x equals to a. But if it is equal, if these two limits are equal, then we cannot take a decision still. Then we have to find fa. And if fa is also equals to all these two, whether this one equals to this one equals to this one, then only the function is continuous at that point. In all other cases, the function is discontinuous. That means we can say if limit of fx, x tends to a minus, equals to limit of fx, x tends to a plus equals to fa, then only the function is continuous. In all other cases, the function is discontinuous. Let us take this case as an example. At x equals to 0, we want to verify whether the function is continuous or not. Graphically we have seen it is continuous. Analytically we have to see whether it is continuous or not. See, limit of mod x tends to 0 equals to what? Limit of mod x tends to 0 plus, we are saying, equals to, we'll say, mod of 0 plus h, limit of this one h tends to 0 equals to limit h tends to 0 equals to 0. Similarly, limit of mod x tends to 0 minus, we can write equals to limit h tends to 0 mod of 0 minus h, and mod of minus h is also equals to h. So limit h tends to 0 equals to 0. Similarly, f0, that is equals to mod 0, and this is also equals to 0. Hence all the three are equal. That's why the function is continuous at x equals to 0. In this way, for any function, remember, if we want to find the continuity of a function at x equals to a, find left hand limit, right hand limit, and f. If all the three are equal, only in that case the function is continuous. In all other cases the function is discontinuous. And remember some important points additional with this. That is, if two different functions are continuous at a point, then a new function comprising their sum or difference is also continuous. If two functions are continuous, then their product is also continuous function. If two functions are continuous, then their ratio is also a continuous function, provided the denominator should not be 0 within the given range.